Welcome. Today the topic I'm going to start is inner sphere mechanisms and outer sphere mechanisms. It is inner sphere mechanisms and outer sphere mechanism. Before we going to start these chapters inner sphere mechanism and outer sphere mechanisms, we have the concepts of one each, that's CAPC. That is where we have that uh, high spin complexes will forms and low spin complexes. That knowledge we should have. And secondly, we should have the concept of labile and inertness. So let me give a quickly recap of how CPC where we have that low spins and high spin. So if I take first about of that concepts of high spins and low spins, for that what we know that that electrochemical series, that is, we say that here we have that electrochemical series we have, that is, first we have I donor, then we have some chelating ligands, then we have the pi acceptor. So that series will be likewise, that delta naught value will be increases. So pi donors we have first, that is halogens groups. First we have that halogen groups, then we have that oxygen donor, then we have that nitrogen donor, and for chelating ligands we have that we can say that it bipyridines, all these things, and pi acceptor ligands we have that Cn minus NO, here 3 CO, this type of ligand. So from here, from left to right, splitting will be increases. This is delta naught means splitting will increases. So I will write that electrochemical series. So if I write that electrochemical series, then first I will write about of this halogen groups, halogens. So that will be ordered from like this. So first will becomes that I minus. After that we have Br minus. Then we have some ligands, that's like SCN minus, and we have that S2 minus, and we have something like Cl minus, then we have like something of N3 minus. This will comes in between that halogens. Then we have that fluorine minus. Then we will go have the groups. This is our this groups, let's say that in between halogens we have these groups, and these groups. So these are that from halogen groups. Up to this, these are from halogen groups. Then we have in spectrochemical series, then will come that oxygen donors, oxygen donors, like we have that OH minus, we have the like O2 minus, we have like that is C2O4 minus, C2O4 2 minus, then we have like O2 minus, then we have OH minus, we have C2O4 2 minus, then we have O2 minus, then we have H2O. This is about of oxygen donor. Then we have next category is nitrogen donors. So for nitrogen donors, we have that is, let's say, NCS minus, then this chlorine, then we have NH3, then pyridines, then we have that En. These are all N donor. Okay, so these are all about of pi donors. Then we have that pi acceptor ligands, oscillating ligands. Okay, so that we have ligands of, now we can say SO3 2 minus, then we have that pyridines, then sorry, this is biphenyl, then we have that phenyls, then we have NO2 minus, and we have ligands of NO2 minus. Okay, then CH3 minus, then we have C6 H5 minus, then we have like PR3, then we have Cn minus, CuO, NO, this type of ligands. So these ligands, let's say from here to here, from here to here, these ligands are generally pi acceptor ligands. These are pi acceptor ligands, and these are the pi donor ligands. So this is that electrochemical series. What says that electrochemical series? This is about of that electrochemical series. Okay, so from this we say that first halogens, then oxygen donor, then nitrogen donors, then we have that pi acceptor ligands. So how we say that? That splitting will increases from this. So here the splitting will be less, here the splitting will be high. So here splitting is, that is delta naught is less. So that is explained by MOT, that CFT, that is LFT will explain this, that we already discussed. So here that delta naught is high. So this is about of that electrochemical series. So why I am talking about a electrochemical series? So whenever we calculate that complexes is given for that high spin and low spin complexes, so if delta naught is less, on that case, this is generally we have high spin complexes, and if delta naught is high, then that is low spin complexes, means pairing will occur. Pairing here, now pairing occur. And another concept we should know, that is the concept of labile and inert. Oh, sorry for that. So this is the electrochemical series. So what you see that for transition metal complexes, we are having the transition metal complexes. So these transition metal complexes, we are interested in 3D series. Okay, 2D series is not there, 1D series is not there, 3D series, 4D, 5D is there. Okay, so because the d orbitals comes after this 3D, then this 3D series is there. Then we have transition metal complexes of 4D series is there, complexes of 4D, 5D, 6D series. Okay, so for this we are interested with this transition 3D series, because for 4D, 5D, that is always it have that low spin complexes. Okay, so in irrespective of this ligand, that electrochemical series, you will not look simply if it is 4D, 5D, 6D, then always we will do that low spin complexes. But for 3D series complexes, what we have, that we have to clear that 3D series, and that has to be oxidation state. Oxidation state is +2 or +3. Then we will look. Otherwise, if it is transition metal complexes, that is also fall in this group. If that is transition metal complex, and that is 3D series, but the charge oxidation state is +4, +5, like this, then also that always low spin complexes will happen. So we only look that transition metal complexes. If it is 3D series, then only we will look about of this electrochemical series. And if transition metal complex 4D, 5D, 6D, then there is always low spin complexes irrespective of ligands. And transition metal complexes, that is 3D, but that oxidation state is greater than +3, that is +4, +5, +6, then always low spin complexes. For this we will not look that electrochemical series. The electrochemical series will be looked only for this. Okay, here also we look, but here always that this is fixed, that is the low spin complexes. For this, high spin or low spins both are possible. So for this case we will look that electrochemical series. Here both low spins and high spin complexes are possible. So for which case that is high spin, and for which case this is low spin complexes, for that what we note that if it is 3D series and +2 oxidation state, then what do you look that till En, it means that including En all always will do that high spin complexes. till En including En, that is they are weak field ligands, and it is that high spin complexes will happen. Okay, so this is the first point for 3D series, and it is close to oxidation state. And second point is 3D series and plus 3 oxidation states. Then what you look that till now water and including water. Till means including water. Okay, till En means including En. So here that is weak field ligands and Hc complexes will happen. And for this case the exceptional is there. Okay, this is A. For this case exceptional is there. B case, that is 3D series and plus 3 oxidation states. Exceptional is, or I can write directly here, but one exceptional that is cobalt 3 plus. Only cobalt 3 plus, one exceptional is there. All the cases this is valid, only cobalt 3 plus. Cobalt 3 plus, what happened? It is that cobalt 3 plus everywhere we will find that low spin complexes. All ligands are strong field ligands, that is low spin complexes, except that is halogens. Halogen group means that this group also come, that is, let's say that halogen groups X minus, then that in between the halogen groups are there like N3 minus, H2 minus, this type, this groups also fall, that N3 minus, SCN minus, H2 minus, this group. Okay, so these groups SCN minus, so except these groups all ligands are strong field ligands for cobalt 3 plus. So these points you have to remember. First point is for plus 2 oxidation state till En. En means you know that ligands, that is we have CH2 NH, then NH2, this type of groups. So here this is that En. So still En, this electrochemical series, these groups or plus 2 oxidation states, that is till En means up to here. Up to this, okay, up to this all are weak field ligands, including this all are weak field ligands for plus 2 oxidation states. And for that plus 3 oxidation states we are interested up to this water. Okay, so up to this all are weak field ligands for plus 3 oxidation states except cobalt 3 plus, that is for cobalt 3 plus all are strong field ligands except these halogen groups. So this is what that high spin and low spin complexes says, that where we will do high spin and where we will do that low spin complexes. And next concept is important, that is concept of labile and inert. So here we see that where I am taking low spins and high spins. Let's say if I will give an example for this case. So let's say one example, let's say Fe H2 3 plus is there, and Fe NH3 3 plus is there. Okay, and cobalt, let's say NH3 3 plus is there. So here that what is the CFSA? Then this is Fe 3 plus, so this is D5. So here it is water and this is 3. Okay, so we see that for that plus 3 oxidation states, that still water, that is weak field ligands. So this is water except cobalt. Okay, let's say here again we have that cobalt water 3 plus. So here in this case D5, and here we say that what still water that are weak field ligands. So this will going to be weak field ligands. Let's say D5 1 2 3 4 and 5. Okay, so again we have that, and this FeNH3 2 plus. Here also we say that this is D6. Let's say it is 2 plus, then D6. So for we say that for plus 2 oxidation state still En. So NH3 last is En. So this is also again will be a weak field ligands. So this will be 1 2 3 4 5 and 6. Now if we have that is cobalt NH3, then for cobalt that accept halogen groups, for that is N3H2 and Sc minus, all are strong field ligands. So this is comes to be strong field ligands. So this will be ligands will be 1 2 3. This is D5, sorry, that is D6. So 4 5 6, this will happen. For this case cobalt water, this is also, let's say if it is have that halogen, F6, then this will have x minus 6 to plus 3, then this is going to be x equal to plus 3. So here again this will be weak field ligands, because if this is there then there is weak field ligands. Okay, so this will be 1 2 3 4 5 6. So this way we can say that which is strong field ligand and this is weak field ligands. Okay, next concept we will look at concept of labile and inertness. So for this case only you have to remember that is if electrons enters in Eg orbitals, then it is labile, and except is always there, exceptional is D8 case. This first point you have to remember. And second, from according to BBT, this D3, that D1 and D2 are labile. This is from this exceptional, but this is explained by BBT. Okay, so or you can say that D8 and excepts D1 and D2. This is also fine. Or you can point this is another point, D1 and D2 also labile. This is explained by BBT. Here electrons not enter in the Eg orbital, but this is explained according to BBT, and D1 and D2 are labiles. So only remember these 2 points for labile and inerts. So now we will go to start our inner sphere mechanisms and output.